Hi, I'm Muhammad Irsyad Basuki from FOS 1202 under Group 8. So the point of this video is for me to present my explanation and elaboration about the case study that I have chosen, which is the secret of popcorn popping. Sounds fun, right? I will make sure to make it fun for you guys. But before we get to the fun part, I want to show you guys the contents of this video. Basically the stuff that I will talk about or display throughout the entire video. So for content, of course, we have introduction where I will give you guys information about popcorn or small topics that are related to the case study. And then the video continues with me answering the questions that are given in the case study. After answering all the questions correctly, I hope, I will give you guys my full verdict or my conclusion regarding the case study, and finally the references that I've referred. So now let's begin with what actually is a popcorn and how does it work. A popcorn is basically a variety of corn kernel which expands and puff themselves up when heated. Each kernel is made up of a plant embryo, a starchy endosperm that feeds the embryo, and a solid exterior which we call it as the bran or the hull. Also, within each kernel, there is a small droplet of water that is vital to it popping. When the heat enters the dry kernel, these small droplets of water will then convert into steam or vapor, which will build pressure. When the hull cannot contain the pressure, the kernel explodes or pops. And when the kernel explodes or pops, the starch inside the kernel will then turn into this white, fluffy, crunchy stuff which we call it as popcorn. So yeah, that is how popcorn works. In this case study, the dialogue mentioned how water plays an important part in our daily lives. Everything we do revolves around water. For example, in this context, water generates pressure for kernels to pop. Not only that, water also can act as a transport vehicle due to its ability to dissolve many organic and inorganic compounds. Because of this, it can carry nutrients, waste, and even building blocks around cells. Other than that, do you know how selective water solubility is? Not every substance is able to dissolve in water. No matter how long you stir it up, if the water doesn't allow it to dissolve, it won't. I even stated that water is important because not only it provides medium and environment, but also it is heavily involved in reactions. Done with the introduction, so what's next? We are going to continue with my answers for the 6 questions that has been asked in the case study. So for the first questions, according to Kate, what is the secret of the perfect popcorn popping? So the answer for this is to have the right amount of water. She even stated herself that the ideal amount of water to make popcorn is 14 to 15%. Excessive amount of water will certainly make the popcorn chewy and not exactly the final product that we wanted. Moving on to the second question, and this one needs some calculation. After 1 milliliter of water is completely vaporized to gas, how many milliliters of vapor are produced at standard temperature and pressure? In order to find the final answer, first, we need to find the mass of water. So what formula do we use? Of course, it's going to be density multiplied by volume, which we will get 1 gram. After that, we need to find the mole of water using mass of water divided by the molar mass of water and insert the value, and we will get 0.056 mole. Now that we get the mole of water, we can find the vapor produced. By multiplying the mole of water and the volume that is provided, which is 22.4, we will get the final answer, which is 1.244 liter. But don't forget to convert it into milliliters, which then we will get 1244 milliliter. Next, number 3, write the equation for the formation of maltose, a disaccharide which consists of 2 glucose units, and classify the reaction. So what you guys can see in the slide is what I got as the balance equation. 2 molecules of glucose will produce 1 molecule of maltose and 1 molecule of water. To answer the latter part of the question, I would classify this reaction as a condensation reaction. Why? because a condensation reaction is a type of chemical reaction that combines two molecules together to form a single molecule with the elimination of simple molecules such as water. After 3, it's 4. So for question 4, how many molecules of water are needed to break down an oligosaccharide which contains 10 glucose units? And classify the reaction. So my answer for this question is 9 water molecules. The reason I said this is because in order to break down 10 glucose units, we will need 9 glycosidic bonds between them, where each of them consume 1 water molecule. To answer the latter part of the question, I would classify this reaction as a hydrolysis reaction. We are nearing the end because now it's number 5. For the question number 5, write and balance the cellular respiration equation of glucose. And the balance equation for this is 1 molecule of glucose plus with 6 molecules of oxygen produces 6 molecules of water plus 6 molecules of carbon dioxide plus energy. The latter part of the question asks us to have a comparison between cellular respiration and photosynthesis in terms of products, reactants, energy flow, and the significance of each. I will start with the reactants and products. As you guys can clearly see in this slide, each other's reactant is each other's product, and each other's product is each other's reactant, minus the energy for the photosynthesis reactant. As for the energy flow, cellular respiration releases energy in a stepwise manner as ATP molecules, so we can classify that as the exothermic reaction, whereas photosynthesis requires energy to produce food, so we can classify that as the endothermic reaction. Finally, it is the final question for the case study, which is question 6. The question asks me to draw the structure of glycerol and explain its attraction to water and interaction with water. For the first part of the question, as you guys can see in the slide right now, is the structure of glycerol. It has 3 atoms of carbon bonded to 6 atoms of hydrogen and 3 atoms of hydroxyl by single bond. Glycerol is a hygroscopic trihydroxy alcohol, so the 3-hydroxyl will initiate or enhance the intermolecular forces between water molecules and the glycerol molecules. The ability of these polyol groups to form hydrogen bonds with the water molecule is what makes glycerol easily soluble in water. Now that we are done with the questions, I would like to give you guys my conclusion or my summary on this case study. I would like to conclude that water is one of, if not the most vital substances in the Earth planet, especially for living things. Look how we need water in every single of our daily activities such as cooking, cleaning, and drinking. I would like to say that water is unbeatable when it comes to supporting our daily lives. Also, the reaction that I showed or displayed in this video just shows how wonderful biology is. Every single thing matters, even the small detail, which makes me appreciate biology even more, and I hope you do as well. I think that is it. I'm Irsyad, and I will leave you guys with my references. Bye bye.